Hello everybody, so I'm going to be showing you how to make this tool which I made here, and what this does, it transposes notes from one key to the next. So if we take A, B, C and we want to raise it up by a half step, then it'll give us A sharp, C, and C sharp. So this should work for all 12 keys, and we can also do it in the negative direction, which it'll transpose it either way. And you can also do this, so for A minor, B minor, C minor, it works for that case, and also in this format. So if we see right here, we have a whole song and it is transposed to any key that you want, and you can choose right here sharp or flat. You can choose the accidental, and it transposes every single note if it follows this following format, which is all the notes separated by a space, and then it only takes in the G minor. Now if you have something in the title like A, it'll also transpose that because it just thinks that it is a note that we want to transpose, and it does not know the difference currently. So that could be an improvement, but for now I'll just show you how to do this. So in order to do this, I've already set up the HTML and CSS, and you can see right here it has these properties. So here's the CSS, and here is the HTML quickly. So this is basically just a container, and it contains the input, so we can see the input here, the slider, which is this, the drop down, the sharp or flat, and then the output, which we see right here at the bottom. So currently this slider does not work. In order for this to work, we are going to need to import two things, which are going to be the distance and then the slider value. So we can go ahead and do that. So let slider value equal document.get element by ID, and then that slider value is going to be equal to slider value, as you can see right here. And then we are also going to want to import distance slider, or the distance as it's known. So we're going to call it distance slider, and we are just going to import distance, which is right here. So now if we look at this, we're going to want to change this text right here whenever we move it. So we can do this by having an event listener, and for this event listener we'll just call distance slider dot add event listener. And when do we want this on input? For our first parameter, and then for our second parameter we want to have the slider value, as we saw the slider value, this 0 right here, the slider value, the text content of it will be changed whenever distance slider dot value, so we want the value of distance slider. Whenever that changes, we are then going to want to change the text content. So as we can see right here, when we change the slider value, we get this to change up here. And then we can also do it this way. So we can do function and then just do this, and let's see, and that also works, as you can see. And that is because we're referencing distance slider, this. But that won't work if we do the callback function. So this dot value, that won't work. So it has to be the function, and it'll work either way. So now the next step is handling the input right here. So what we're going to want to do is now call a new function, or make a function called Transpose Notes. This is going to be our main function. And so in doing that, we're also going to want to import more things from our HTML. So instead of doing that, what we can also do is hold Option Shift and then the down arrow, or we could do the up arrow and it'll do the same thing. So we want to change this to input, and then this we want to change it to accidental, and then we'll call it select. And our ID in our HTML is accidental. So as we can see right here, for our drop down is accidental, and for our input ID it is input. Now what is the last thing we're going to need is output. Let output equal document dot get element by ID and output. So there is everything that we're going to want, and for this we are now going to want to know, so in our transpose notes, what are we going to want to know? We're going to want to know the distance, the accidental, and then our input. So first we can start with the distance, so const distance equals, and then we're going to do parse int distance slider dot value. And so why did I do parse int? Because we want to convert this to a string to an integer. As we can see right here, it converts a string to an integer. And then why did we do dot value? Because we want the value of distance slider and not the HTML element. And const accidental equals the same thing, parse int. And for this one we are going to want accidental select dot value. And so now we want to handle the input. So notes array equals input dot value, and if we go right here and we do console.log notes array, what are we going to get so far? So let's put A, B, C, and okay, we need to call this function, so transpose notes on distance slider. So okay, you can see that we get A, B, C, D. Yeah, so that's what we get. And so we're going to want to call this transpose nodes function when are the cases? So when we do something in here, right? So when we do something right there, when we change this slider, and also when we change this key right here. So let's go ahead and add that. So we can do input dot add event listener on the input, and then transpose notes. So we're not going to want to do that because that'll call it when we load input, I believe, but instead we want to pass a reference. And so we do the same thing with this accidental select dot add event listener, change transpose notes, again just pass a reference. And so this is going to call it transpose notes on each of those three cases. So let's see A, yeah, and then we see that that did something right here. A, and then it adds A, B, C, D, and we see that it adds all of that every time we do this. 12, it should add it 12 times, and then flat, it should add it one more time. So now all of that is our event listeners. And that is when our function will be triggered to transpose notes. So now let's continue. We do not want to have the match, have the value equal exactly the input value. So I'll show you right now what we want. Okay, so now this is what we're going to want to do. We say we have the string ABC. We're going to want to have it like this, A, and then a string with an empty space, and then C, and then a string with an empty space. I forgot the B and the C. So B and then C. In order to do this, we can have the use matched, and then we're going to want to use a pretty complicated regex. So it's going to be, where is it? Right here. It's going to be right here in the match. And so this is our regex. And what does this mean? So that has different parts. So this first part of the regex means it matches the white space. This next part right here, it is the main logic for this, and in this part we have this section, which is a negative look behind, and in this negative look behind, it makes sure that it's not preceded by a letter, numbers, sharps, or flats. So it prevents false positives. Like if the capital word, say, is about, so it's not gonna change. It's not going to change the A. And then after that, we're going to have this A to G. And that one just captures the note. So if it is A through G, and then if it is followed by a sharp or a flat, it'll work. And then after that, it looks for the M, so the minor chords. So from here to here, it looks for this or that as an example, and it also includes the sharps and flats. And it is a look ahead for the minor chords, only if they're not followed by more letters. So it won't, say if you write E major seventh, it won't work with that. And then the last part of this regex is going to be this, which it matches any single character that is not a letter, not a digit, or not white space. And this is used to capture symbols like this, this, or this. And so the last part right here, it matches with other word-like tokens and is used for a catch-all for unknown strings. And so after this, we can try it out. So console.log notes array ABC, and then we see that this did exactly what we were describing earlier, the A space B space C. And so if we do A B C testing A minor, E sharp minor, and then D E F G, we see that this is how it's broken down. A space B, testing, and then A for A minor. You see how this is broken down. So right next to each other, there's no space. And then this E sharp is broken down. So we're extracting basically all the music notes, and we're going to handle the rest of the whatever is not notes later. So after doing this, we will want to now also declare a new notes array, and this is where our transpose notes will live. So first we want to loop over every single note, so we can do let note of notes array. So this will give us a loop, and if note dot trim if notes dot trim equals empty, so notes dot trim equals empty, we're going to want the new notes array dot push note. We're going to want to push that note, and then after that we're going to want to continue. So what does this do? And that is going to take the note, and then if it removes the spaces from the start and the end of a string, so it checks if the note is only white space, then it'll just push that white space. So it checks that if there was nothing there. So for example, let's do 1 2 3 4 5 6. So it'll take those 6 spaces and then it'll just push those to our array. So let's see if we can console.log new notes array A B C 1 2 3 4 5 6 D E F G. Okay, so you see how there's duplicates of everything. See, it's because we called this, and then also let me see if I don't do that. A B C D E F. Yes. So it'll push the same amount of spaces as if it sees that that was just pure space. And then our next case will be if the next thing we have to do is let position equal note map note. So this will give us our position. And note map, what is note map? So we're going to write note map right now. So const note map equals, and then this is going to be a hash map basically. And let me just copy and paste this here. So what this does is we give it a letter, a note. So A sharp, B flat, B, C sharp, D flat, D sharp, and then it returns a value. So we can see that we have duplicates here. So why is that? We have duplicates because G sharp and A flat are enharmonic equivalents, and so they both return the same value of 11. So after we see that they both have this, let's see if we can console.log this position. So let's use B and then G. Let's see if that appears. B and G. So we can see that it was 2 and 10. So let's go look at B. It's 2. And now 10 is G. So that is working. And so what are we going to want to do next? If position is undefined, then we're also going to want to push that. So new notes.array dot push note and continue again. So what that does is that when whatever index in our array is not a note, it'll just push it back into a note. So whenever it's not A sharp, B flat, B, C sharp, etc., whenever it's not that, it'll just push that into our new notes array. So after that, we're going to want to let new position equals transpose notes. So here's where our main logic is going to happen. Position and distance are the two parameters that we're going to want to give, and we're going to write the main logic for this transpose, and then we're going to pass position and distance. Perfect. And so let's call it new position equals position plus distance, and then we're going to mod this by 12, and I'll explain right now why this works. After that, we're going to want to make an if statement. If that new position is less than 0, meaning it's a negative number, then our new position will want to add 12 to that, and then we're going to return new position. Perfect. So now again, I'll show you guys why this works. As you remember, we have our algorithm is position plus distance And so we're going to say, if you remember on our map, we had b, and that was equal to, that gave us the value of 2. So if we type in b, we're going to be at position 2. Now say we want to transpose by 2 half steps or a whole step. So 2, and then that'll equal 4. So now if we look at our map again, so what was at 4? At 4 we got either C# or D flat. So this is the new note, because in between, if you remember, there was C at 3 and then C# at 4. So now we're going to have that as our value, so that it equals C#, as we can see. Now what about when we are adding to this, but say we are all the way, our position is 10, for example. So our new position is going to be at 10. And then we want to go a distance of 4, so we want to go up 4 half steps. In this case, position 10 will be G, and so if we want to add 4 to it, of course that'll be 14. But our thing actually ends at G#, which is 11, or A flat, which is 11, so it does not go higher than 11. So then what we want to do is loop around, actually. So we'll want to loop around and go. So we'll start here, we'll go here, that's 1, then 2, which we land right here, 3, and then 4. If we count that, 1, 2, 3, and then 4. So we'll end up at B, and B is at position 2. So if it is at position 2, how can we get 14 to equal 2? We can obviously subtract 12 from it, but what we can also do is modulo 12. So if we do this, we divide 14 by 12, which is obviously 1, and our remainder is then 2. The answer to 14 modulo 12 is going to be 2. So then now we get B. And so there is also the case, if you remember our initial demo, we also went backwards. So what if, again, we started at 2 and we wanted to go back by 4? So with that, let's try that out. So 2, and we wanted to go backwards 4. So 2, obviously we know that that equals -2. But wait, we don't have a -2 in our map. So we can do modulo sine 12. That should equal 10. But in JavaScript, this is just a remainder. So that is not going to give us the correct thing. This is going to give us -2 actually. So that was what the next line was for. So if it is negative, then we want to add 12 to it. Add 12 to it. And then that'll give us our correct result of 10, which is G. And so if you see right here, it handles the going backwards and going forwards, and it gives us the correct transposition. Back over here, we return the new position, and in the new position we'll call it new note. So let new note equal position map new position. So we need a position map now, so that will do the opposite. So let's define that. So position map will be slightly different. Why can't we use just note map again to do it back? Because we have accidentals and we want this time to input the number and then get this in return. So we can see right here that A obviously is going to be 0, then A sharp and B flat are both going to equal 1. So now this is going to be an array. So what we can do in order for us to retrieve that is to check if array.is array new note. So if it is an array, what are we going to want to do? We are going to want to have new note equal, if accidental is either a 1, then new note okay, so if accidental equals a 1, if we select it right here, sharp, it'll be a 1, remember. If it is a 1, then it'll be the first value, which is always a sharp. As we can see right here, it's always a sharp. Else it'll be the other one. So after that we can do new notes array dot push new note. And then after that, what we can do is output dot value equal new notes array, and then we can just join it together. And let's see if this works. So it doesn't work. Okay, so I found the problem. I had put transpose notes instead of transpose, and so if we see A, B, so now we get this. And so from that, it should handle everything. So A, B, C, D, E, F, G. Let's see. Yeah, so that transposes everything to that note. And if we put the key here, so this is in the key of A minor, we can then actually get every single scale here. And then we can also of course choose the flat or sharp. And then if we type in words, this is a word, or this is a sentence, it will transpose A because it believes it's a word. It believes it's a note. But aside from this is pretty much working. And that's going to be it. and hopefully you guys enjoyed, and hopefully that helped you in some bit. And this was my transposition algorithm, and thank you for watching.